Okay, let's let things load and see. Check mic. Good, sounds good. Hey everyone, good morning. Hoping you had some good fun doing a bit of problem solving beforehand. We weren't going to meet on Thursday, so that's why I kind of wanted to do that before class. Going forward, we'll probably do Thursdays as exercises and Wednesdays as longer lectures, with maybe a short lecture on Thursdays, depending. But since we weren't meeting on Thursday this time, I decided to go ahead and have you work some stuff from last week so you can get a bit of practice in. This week we'll be going over 4.2, which is a relationships, which goes over inheritance. And so, yeah, that's what we'll be doing today. We'll be doing a little bit of problem solving with that, improving our coffee house example, and I'll show you how all that works. And there's some keywords that I didn't include in the book that we will be learning as well, and that will help you find things that are of specific types. So anyway, let's see if we can get started over here and make sure everything goes well. Let's start from here. And there we go. Okay. So this particular section of the book is a relationships. Now we're going to explore this type of relationship as a fundamental concept in object-oriented programming. Basically, it helps us model relationships when one type of object is a more specific version of another. So you'll see how to create class inheritance and hierarchies that represent these is-a relationships, and see how to visualize them with UML diagrams like we did with association and composition, and understand how to implement these in code, which we will do at the end as we did last time. By the end of the session, you should be able to understand a little bit of how inheritance helps us create organized and logical class structures that mirror the real world. And so let's begin by looking at what inheritance is and how it helps us write better code. So on inheritance, we have a relationship type that represents one type is representing a special type of another. Oop, and my everything just died. Give me a second. Everyone, yeah, everything, my whole USB just died, but I think we're okay. Just have to get that back up for a second. I think. Let me see. 1 sec. Start from here. Sometimes that's been happening lately. I don't know why. But okay, we'll do that. There we go. So back to being is a type of. So we can say that a cat, for instance, is a more specific type of animal. That's an easy example to go with. And you'll see how to actually use these different objects and these relationships to form hierarchies of things, like I mentioned, between parent and child before. This is very much, you have a parent class, also called the base class, which is very specific, very important to know that it actually is called the base class. And then you'll have a child class, which is called a derived class. It's not as important to know these are called derived classes, but the reason why we need to know it's called a base class for the parent is because there's a base keyword that we use. And so you need to know that. So a good example is like streamable content, for instance. We have a movie as a special type of streamable content, a TV series is another type of streamable content, and a podcast is another type of streamable content. So those are all specific types of a very generic streamable content type. Each of these inherits basic features such as, oh, the title and duration, but they add their own unique features. For instance, a TV series might have a number of episodes, whereas a movie wouldn't have that. So, are there any things that you can possibly think of that would be specific types of something else? What features do they share with the general type? And what makes them unique from their general type? When you're thinking about inheritance, try to think of examples of these. In code, it's not too difficult to come up with how to do the very basics of it. So when we want to have, let me get my laser pointer out. When we want to have inheritance in the code, we have a parent class called the base class. In this case, it's streamable content. And then we also have the child class. And to make a child class, we put a colon in between the child class name and the parent class name. So here we have a child class TV series, which is has a parent that inherits from streamable content. That means it gets all these properties and methods available to TV series as well. So that it inherits all of those sort of properties, and then you're able to change them. The base class itself, the parent class, it provides general attributes that everything shares, and then it has the core functionality, like get info, for instance. And then the child class will add more specific content, such as it inherits the base features, adds unique features, and then if needed, we can override things, which we don't have an example of here, but we will see an example of. So for right here, we would just use these directly into a TV series. And whenever we go to create our TV series, we could have a duration, we could have a name, a description, and we could use get info without changing anything, but we will want to eventually have the ability to customize. Even if you make streamable content private, you cannot make streamable content private. In fact, it's a top level class. You cannot make top level classes private. I think what you're trying to ask is if you make something inside of streamable content private. And in that case, it doesn't get inherited by the child class. So this the top level classes can only be public, file, and let's see, what else could they be? Public, file, and I think there's one more. They can't be private. Um, they can't be protected. So I'm trying to think if there's any more. Public and file are the main ones. Internal. Internal is the third one. So those three things are the only things that top level classes could be. And by top level, I mean they're outside of anything else. Now, if you nest a class within a class, then you can have more of a private member, but that's not something we're going to go into for this course. But no, you can't make this private by any means. It would just crash. Um, so that would have to be public, and this will inherit any of the members that we are giving access to. And yes, you can prevent that by making it a private member, which can only be accessed by that specific class, which we will get into actually right now. So there are different access modifiers that help us with inheritance. And what we need to figure out is what should children access, what should stay private or protected, or maybe some of these others like protected internal, private protected, and what needs to be public. So public, as we've known from the beginning, is the most access you can possibly have. It's accessible within the file, within the class, within derived classes, within the same assembly, meaning child classes, within non-derived classes, meaning just regular classes that don't have children or parents, within derived classes or children classes in other assemblies, and within non-derived classes, meaning regular classes again, in different assemblies. So it's accessible everywhere. This is what I meant by public being the thing that gives you third-party access as well, because you can access it within different assemblies. Protected is the one that's considered basically in the middle between public and private, and it's almost sort of in the middle there. The main thing that it does is that it allows classes that are children to be able to use its members. So, for instance, it can be used within the file, like public can, within the class, like private as well, like public as well. Pretty much everything within it can do within the class except for file. And then derived classes, it can do within the same and different assemblies. And that's where it makes it a little bit confusing because not everyone understands that protected gives you access to a child class within the same assembly, but also if you have that accessible within a third party assembly or a third developer assembly or a different assembly that you're developing. It doesn't necessarily have to be third party, but it's easier to understand that way. So that is usually considered the midpoint. Personally, I would consider more the midpoint actually a bit more like private protected. As you notice, there's like three check marks and three X's. But this was protected was there long before anything else was. So it used to be public, protected, private mainly. Internal was always there too. So for internal, it's pretty much everything that public can do except for in different assemblies. That's what it prevents. It prevents anything from different assemblies. Protected has slightly different access in that it can do other assemblies for child classes. So that's a little different. But private protected is probably the one you may want to pick nowadays. Protected used to be the default when you want to do child classes and such. But private protected prevents anything from different assemblies, also within non-derived classes. So it's kind of what you think of when you think of this variable can be accessed by the child members. And you don't have to think about is it within the same assembly or not because it won't allow things in the other assembly to be accessed. So it has to be within the same assembly. So that's why I would normally consider as closer to in between public and private. And for private, it's worded a little weird here, but this is directly from Microsoft, but it is within the file, but it's not everywhere within the file. So that's why it's still considered the most protected there is, even more protected than file, which has more X's here, because you can't access it anywhere within the file, only within a specific class within the file. And they had to put it that way just because it is within the file, but to be very specific, it cannot be accessed outside of the same class it's defined. So that makes it more protected, more encapsulated than file is. File is accessible within the file, and that's it. You can use those for helper classes. But it's newer. That one is, I think, 11.0 when they put that in not too long ago. Um, but protected and private and public. See, those public, private, and protected are the most three that you use. I would probably switch over to private protected to be honest these days because that way you don't have to worry about third parties getting access ever. So this gives a little bit of extra protection against third party access or other assembly access. Whereas internal, that one is just like public, but without any external access. It's a little bit less encapsulated or less protected than protected or private protected is, in that you can access it within non-child classes and non-parent classes. So you can give it this the protected has to do with inheritance, protected internal has to do with inheritance, and private protected all has to do with inheritance. Whereas the derived classes for the same assembly internal can be done. So in internal, you can think of a little bit about child classes and parent classes, but the ones that are mainly are the protected ones. This one you cannot access from third parties, so don't typically consider it. Public is accessible everywhere, so of course it's accessible within child classes and parent classes and all that. So when you're thinking about these, you have to think about, well, exactly what type of access do I need to give this variable? And so we use different access modifiers for that. The protected members can be used by child classes and they're hidden by the rest of the program. And we say assemblies here. Now, I just want to give a very, very simple definition on assembly, which is just the fact that an assembly is a collection of code, such as classes, methods, and files that, like images and metadata or configuration settings, that are all processed or compiled into a form that the computer can understand and use. Like in Windows, that would be like a DLL or an exe file. On Mac, it might be an SO file or DMG file, similar with Linux for shared object files. So the assembly that's talking about is something that's compiled into like a library or an executable. And you can have multiple different libraries that you manage to keep things more modular. So if you have multiple types of modules, then you can say, well, I don't have to recompile the entire code every time I do a version update if it's just code within that module that changes. That keeps your updates smaller whenever you do version changing. So like if you have a new feature that you're going to implement and it's just changing in one DLL or one shared object or whatever, then it can easily be updated without having to recompile the entire code. And that makes it a lot simpler for people to update things without having to download like, however many gigabytes your file might be. It can be just a couple of hundred megabytes instead, just representing those classes and stuff. So those specific ones will be updated. That is what a shared library or an assembly, which is a compiled piece of code so that is compiled together as a unit. And that's what it's talking about when it's saying same assembly and different assemblies. Does it exist within the same shared library, or is it in a different shared library? And so that's why I usually say third-party developer, first-party developers, because it can be easier to think of like who has access to it. But really, that's what it means, is that this all these files are compiled together into one big O module. Okay, and so in a UML diagram, we represent this with an arrow that is hollow on one end, all pointing towards the parent. So I mentioned streamable content before, and you can see a lot of this is protected, which is the asterisk. So we looked at the tilde last time, which was internal. Protected is all of the asterisk one. Plus is the public, and if we have any minus, that would be private. If you want to do private protected, there is no standard for it, but typically you just combine the two symbols of private and protected, that sort of thing. Now, if you have something that is able to be overridden, which we'll get into, then we usually list it in italics in the parent. And then if you do override it in the child, where you put like a slash in front of the name. And that lets you know that, hey, this is overriding what was in the parent. And this says, oh, this is able to be overridden. So the single triangles points to the parent. The children add features. So we can see that this all has tile duration and play, pause, and stop methods, but the movie has a get movie info and a director and a rating, whereas TV series has episodes, the current season, a way to add or remove and download episodes. A podcast is very similar to a TV series, and that might be something you consider refactoring later because they're so similar. Um, the podcast has a host, and that adds a feature to a TV series, but since they're so similar, you may later consider that these might be combined in some way and have a hierarchy relationship between them. So they share common features in the parent, they have unique features in the child, and so we not want to think about like what other features might these classes share and what makes each child class unique, and how does the diagram itself help us understand these relationships. We've seen how we can show in the UML diagrams the flow from one to the next. This all again points to the parent. Just like the composition points to the whole, this points to the parent. So let's see how we can actually do a little bit of that. Pardon me. Still got a bit of a virus thing, but I'm getting there. Okay, so in code, we have a way of doing inheritance. We can say the colon. Well, first of all, let's look at the parent class. We got the public class book, which has a title, author, ISBN, a page count, and an enumeration, which is shown in this chapter. So hopefully you've gone through that a little bit, but this is just like a named integer, basically. For book status, I'm giving the number 0 borrowed, the number 1 available, number 2 reserved, and number 3 lost without having to remember what 0, 1, 2, or 3 means. I just have to say, okay, well, what is the current status? Is it borrowed? Is it available, reserved, or lost? And internally, it stores that as an integer. So it's a named integer. It's an enumeration. It's what it stands for. And there's a good deal of information about that in the book. So hopefully you'll go through that. Then we have a constructor for the book, which takes in the title, the author, the ISBN, the page count, and whatever the current status is, and just sets the variables up. It has one method, display info, which just writes the information about the book, its title, author, ISBN, page count, that sort of thing. And then we finally have a child class. And in the child class, we have an ebook, which has a few different properties than a regular book. An ebook, for instance, has a file format that might be in. There are different file formats for ebooks, and it has a file size in megabytes. So we have those two just to illustrate that these are different for an ebook than, say, a printed copy book. For the ebook, we would pass in every single thing to the constructor, but we don't have to actually use everything in the actual ebook constructor because we can use this base keyword, and base calls the constructor here. So base would call this with whatever we pass in, the title, the author, the ISBN, the page count, and the status. It calls that with those and says, okay, I'm going to create a book, and here's the very first part. And then for the ebook specifically, I'm also going to include the file format and file size MB. So the very first thing this does is run the constructor for book, and then it runs its own constructor. So that prevents you from having to retype title, author, ISBN, and page count all throughout ebook because it's not necessary. You can just call the constructor for book, which sets up these. And then you set up this variables for the ebook. So let's see if there's anything else on that. Yeah, we got this. Okay, so do we have any virtual yet? No, I think that's coming up though. All right, I'll get to that. But this is how you set up basically a simple little class structure with that inherits from book of the ebook. Just the colon right here. And you can only do in C sharp one inheritance, so you can only inherit from one parent class. That's different from some other languages which have multiple inheritance, but C sharp handles that in a different way that we'll learn later. For inheritance, you can only inherit one class, so you have to keep that in mind. It's a parent-child relationship only. There's no extra thing here. But you can do other things, and like I said, we'll learn those other things that we can do. Okay, so what if we want to actually have the ebook override a method from book? Well, if it wants to say, for instance, display the info slightly differently than the book does, in that case, you might have a virtual method that gets overridden. If you mark a method as virtual, you're specifically telling a child class that it's possible to override this and put your own implementation into it. You don't have to, but you can. That's what virtual means. You don't have to, but you can change it into what you want. In this example, we've made display info, have it be different from the regular, the parent display info because we actually have more information that we can print. I just use file format here. So for the display info, we marked it as virtual, which goes in between the access modifier and the return type. So public, virtual, void, display info. So that says, okay, I can override display info in a child. Cool. Now we have a child, and I'm going to override that by using the override keyword. So to override a virtual method, all you do is use the override keyword. It's not that difficult. And then we can call the actual base methods with it just like this. We can call that method without any changes and then put our own spin on it afterwards if we want. We don't have to do that, but if we want to just display the title and author, there's no reason to repeat that code. We can just say, okay, I'm going to call the display info from the parent class, and then I'm going to call my own, put my own little spin on it by putting my own information about the file format here. So there's a couple of things on the override. It has to have the same name. It has to have the same signature, meaning the access modifier and the return type have to be the same, and it has to have the same parameters. So basically, it has to look almost exactly the same as the method that's calling in order to be able to understand that these are the same method. So this is the method that's overriding. So for this, we've just marked methods in the parent as virtual, and if we want the child to be able to change it and use override in the child to provide their own version. So you can think about how different types of content might need to play differently based on for instance, let's say that we were doing the streamable info or streamable content. If you are doing a podcast, you might want the ability to play at a faster speed. Some people like to listen to those at 1.25 or 1.5 speed instead of at the slower 1x speed. So you might want to have the ability to override the play speed. And that would mean that you would override that play method that we had earlier to do something slightly different. And, that's allowed typically on online streamable content for sure. So, how might a movie differ from playing a podcast? How might those two differ if you want to play a movie versus playing a podcast? And when would you want to keep the parent behavior? Something like we did here. And when would you want completely different behavior where we didn't even use the base class? So those are things we think about when we are developing this relationship. The sealed keyword prevents any further inheritance. It has a few advantages, but this means that, okay, I'm going to create a reference book that's from a book type, but I'm not going to allow anything to be created from reference book. So this is as far down as the inheritance will go. So it's a public sealed class reference book that inherits from book, and you cannot inherit from reference book. So it's like saying this class is complete as it is. When we seal the class, no other classes can inherit from it. So this can be useful when we want to make sure that behaviors don't get changed in ways that we don't want developers to change them. And it's like making sure that all movies are played the same way, for instance, or making sure that that we don't have anything that inherits from, say, a cappuccino. If we wanted to say the coffee example, we just have a regular cappuccino, and we don't want to have any further inheritance to have very specific types of that. If we want to control our menu in that coffee house more directly, then we can seal it off from people trying to change it further. Why would you do this? Well, it signals to the designer that you have a very clear intent that this is a complete class as it is. No extra changes are going to be made to it. But it can also be a bit performance enhancing in that whenever the compiler has to search, or even during runtime has to search for additional classes that are being inherited, it knows that it doesn't have to do any searching past this. So this can be a bit more performance enhancing for see if you seal your classes up. But it does limit the flexibility, and that can be a problem, especially when you make things public. And now when we make things public, we already know that third parties are probably going to have access to this code somewhere. So if we seal it off, it's going to be hard for us to unseal it, because then we have to communicate to whoever's using this and say, oh, I'm not going to seal this anymore. So as soon as you make something public, you have to worry about whatever thing you're going to be doing to that public class. And sealing is one example of that. When people start to use your code, it gets to be hard to change your code, because at that point they expect it to work the same way every time they use it. They don't expect quick changes to be happening all the time between methods or classes. So whenever you're thinking about this, don't necessarily limit the flexibility. You can always seal it later if you want to. But if you do have a very specific reason for sealing from third parties, for instance, then I would seal it right away if you absolutely know for sure that it's going to be always sealed, because you're going to make this public already. You can also prevent and make it internal and then decide to open it up later. Sorry, later for third parties, and see if we can at that point say, okay, well, this is internal, it's been sealed for a while, but we're going to test out just internally to see if sealing versus unsealing makes a difference for what our model is. And as soon as we figure out that we're not going to seal this anymore, then we can figure out, okay, now we can make it public and make it accessible to third parties, because we've tested the sealing properly, whether we wanted this class to be sealed or not. So now we know it's not going to change in the future, because any future change to a public class becomes very difficult. Any public method becomes very difficult to change. You have to take years, most likely, to get these changes made, because people start using them, and then you have to deprecate a method and say this is not going to be used in the same way anymore. And even after you deprecate the method, you have to keep it around for a while with that same signature and same old code, and have to migrate people over to your new version. So that's why access modifiers get to become important, especially when you're thinking about using public everywhere, because people will start to use your code. And you need to make sure that whenever they are going to start using your code, it's ready to actually be used by them. Because if it's not, then they're going to start using it in ways that you didn't intend, and you're going to be stuck with that. So it can be very difficult to be stuck with something that you set as public to begin with. So that's why you have to always consider what you're modeling, who has access to it. Okay. So so inheritance is good for when you have a true is a relationship. It's powerful, but it should be really carefully thought out. Use it when you have a clear relationship that this is a relationship where one thing is truly a type of another. Don't use it just to share code, because you know it does allow you to use protected and things. That's what composition is for. A movie is a type of streamable content, but a movie doesn't have doesn't have a type of streamable content. So it is a type of one, but it doesn't have other types of streamable content. So this is a very much a relationship. Make sure that it definitely represents that type of relationship before you start using inheritance. It's good for shared behavioral patterns. Whenever you have certain behaviors that we've looked at already that share very common features. And it's good for natural hierarchies whenever you have a specific parent-child relationships that's very obvious in code. If you can think about the coffee house from last time, you can think about a menu item. We made a very generic class, and we were thinking about making that a parent class of drink and maybe pastry as well, and maybe drink would have its own child classes like cappuccino and that sort of thing. But those are very natural inheritance that comes up, making those certain specific types. Because once you know that a cappuccino is a type of drink, then it's in your mind. It clicks that you're saying that, okay, this relationship is the best fit for it. But don't use it just for sharing code. Don't use it for where you have unrelated features. And don't try to force the relationship into something it's not. There are other ways to make things shared, and like a composition. We don't necessarily have to have inheritance to share information between classes. We've already seen how we do that with the implementation last time, where we didn't have to share certain things. We just have to make sure they work together properly. Okay, so we've now looked at how inheritance helps us create organized class structures that mirrors real-world relationships. We've seen how to use virtual and override for flexible behavior, how to use access modifiers to control what the child classes can do, and when to use sealed to prevent further inheritance. We're going to use these concepts next into our coffee house system. I'll probably give us a break for a bit, yeah, about a 15-minute break before we do that. But we're basically going to have a hierarchy of drink types. We'll have different drinks like lattes, cappuccinos that inherit from a base drink class. And we're going to remove that connection from last week where we had the drink be a part of the actual of having a menu item inside the drink because we are going to make a drink a type of menu item. So coming up are going to be the coffee house enhancements, drink hierarchies, and specialized behaviors. So I'm going to give us a 15-minute break, and then maybe I'm trying different music this time. Maybe they'll like my music this time, but we'll see. If not, then it's going to be silence again. But I'll give us a little break, and then we'll come back and do some code like we did last time. All right. So 15 minutes, yeah, about 11 a.m. Hey, welcome back. Welcome back. All right, so we have a few things to modify on our UML diagram because we're going to get rid of this link between menu item and drink and make menu item or a drink a type of menu item now. And probably also move what the barista can do, I'm thinking, because the barista can make more than just drinks. They can make menu items of different types. We're just going to have, think drink for now as our menu item, but we can think about adding pastries later. But let's go ahead. I'm going to set and setting out the requirements first and just change them a little bit. So I'm going to open up the coffee house from last time in VS Code and just change up our requirements a little bit. All right, so let me see. What do I want to add? Added some things last time. What do I want? And here we are. Yeah. All right, so let's just let's be a bit more specific, I think. The coffee house owns and manages all menu items, and that should be a composition relationship. It's basically the second part of this. Let's see. Menu items, drinks, pastries, pastries. Belong or we'll just say we're just going to say our internal to maintain the composition. And let's see, third, I want to have the yeah, we can put this first. Type. Here we go. The third thing I want is public methods. Will be in the coffee house. We'll give access to like the menu stuff. Let's see. We'll provide access to menu functionalities. And what else? Menu item. Right below it, not in front of it. There we go. That will provide the common features like the name, price, and description, since it's going to be a parent class. Name, price, description, something like that. And then we are going to have drinks inherit from the menu item. And let's see. And there, we're going to have them track the barista, but I think we're going to have it here actually. And track barista. Makes more sense for the barista to be up in the menu item level instead of just drinks, because they make more than just drinks. And let's see. And what else do we hunt? We can have some specific features, and we want to still keep some of these. This time I'm going to say I don't need that since we already have that. All right, and yeah, we pretty much have this already. We don't need to change that. We didn't add remove last time. I think I just forgot, but it was simple to do. We can have this still all be done the way it is, except we're going to change up the code a little bit. But we also want to be able to have specific, the specific drinks have different features. And just for this, just for examples, the latte prices can vary, and that's based on the milk type. Like for whatever, whatever denomination you want for alternative milks, soy, almond, coconut, that sort of thing. It doesn't have to just be latte on that. You could do like an Americano or something. I just want to show different ones doing different things. Cappuccino, for instance, that will have an extra shot. Sure, why not? And we'll add 5 point. 50 is for okay. And I think that's all I want to do except for maybe Americano, I think I'll do. Americano, and that will be can be extra strong and no charge. I'm not going to make the pastries this time, but I want to keep in mind next time that we will probably add to this more. But for this time, I just want to get some simple things going with the inheritance. Okay, so we need all that into the UML. So first of all, there's a bunch of little methods that we have here that we want to change up a little bit on. And nice that this sort of bends over when that happens. There we go. Okay, first of all, I want to get rid of this from the drink because it's now going to be a type of menu item. I'll get rid of the lines and move it over. And now we will have a composition. Yeah, that's not really where I wanted the arrow. Okay, there we go. Yeah, I know. It's like beautiful, beautiful arrow I have. I will get there eventually. Try that. Zoom in a little bit. Or I could just like drag it again. I love when it does that sometimes. It's like right there, then no. Just wants to like go all the way over there. Try it one more time. It's taking forever just to draw these arrows. My mouse is part of the problem. I need to replace it. It like does not want to stay dragging, so it lets it stop. No, not text. Thank you. Just drag over here. There you go. Close enough. That's close enough. I just because I'm gonna have a lot of these to draw. I'm not too terribly worried. And see how that happens. We'll just leave it like that. Okay, we leave that like that, but we need to change this up to a hollow arrow. Is that you? Okay, so that's a inheritance relationship. Notice that this is an association relationship, this is a composition relationship, and this is an inheritance relationship. And we're going to have several different ones. Instead of made by on the drink, I think I'm going to move that to menu item. And let's see. There we go. And all that's going to be internal, at the very least. And then we'll make everything from drink also internal since it's now a subclass. And barista is going to be moved, review, to the menu item to have an association with that instead of an association with drink. See, my mouse isn't the best. Need to replace this thing. Yeah, yeah. There we go. Yeah, but here, good enough. All right. Yeah, it's really hard to drag with my mouse these days. Okay. So we still want the same information from barista, but we're going to track who makes these. I already messed up my nice little arrow again. Which I'll get there eventually. We need to get a better mouse than this. Move you over here, be good. If I can. Maybe not. I can get it there eventually. Okay, mouse. You're going to be bothering me for a while. If I could do this with a keyboard instead, it'd be great. Over there. There we go. Okay. Drink again is composition, so we're going to change the air or not composition but inheritance. And then barista will have like this. We still have a composition relationship with menu item. We're going to get rid of the list of drinks made, most likely. It's going to be a little bit more complex, but we're going to look through menu items and see if something is a drink and still have the show all drinks made, still have the make drink and all that, but we're just going to change it up a little bit. Now we need the subclasses of drink as well, so I'm just going to copy and paste, and we're going to do 3 of those, which was latte, cappuccino, and Americano. And cappuccino and Americano. Let's see, what do I have on these particular ones that I required? Just looking at my requirements for them. Somewhere around. Okay. So, need some information on these types of drinks. I think we could do for most of them will have a milk type, I think. Yeah, we could probably do as part of a drink a milk type. And let's just do that. Okay, so we're going to call that probably, should it be private milk type? I think I might just make a private. I don't think I really need to access anything from outside of drink of the milk type. Yeah, maybe. We'll see. And it's going to be of type milk type. It's going to be an enumeration. As I mentioned before, those are named variables. I'm still going to have to get info here. And since that's private, I might want to make it a field. I might want to keep it internal instead of private. We'll see. Sometimes I play around in my mind on what I want these to have. But for the latte, we just need we can probably also put a base price for drinks and then have an extra price or something like that. So we'll do that with a drink. Let's have a price, I think, and be a decimal. Let's see, we probably have a price here actually. So we don't actually need that because it inherits from the menu item. But we do need is probably a way to override the price from latte, cappuccino, and Americano, and maybe even drink, depending. I'm going to have only the specific ones made, so I'm going to keep this not being able to something that we actually spawn on its own. Instead, we'll use these, the cappuccino, the latte, and Americano. Okay, so for that, I will have let's see, we already have a price, so I'll have a way of doing I think it's an extra shot for, what was that? What did I say I had? Latte can vary price based on milk type. So we already know the milk type. We can probably do the same for the rest. That's fine. So we will probably update the price to be something overrideable. So this, I think we'll have this be something that we can override. And instead of just a property, we might want to have some way of actually overriding that price and have like a base price and total price, something like that. Don't know yet, but maybe a method. I think a method and probably a method over here if I can. That I can drag with my mouse. Be great. Okay, and let's use the line. Can we do that? Let's try it. I'm just going to try doing it simply instead. Okay. Not get too overcomplicated today and just keep things simple of getting the inheritance relationship to work. So for the latte, I will just say you can have a get info, but not really do much other than that. And for cappuccino, and let's see, since this is overridable, I'll need to do italics. And since this is going to be overridden, I'm going to do slash. And same with this. Cappuccino, I think I want to have an extra shot for, I guess. Yeah. And that's just going to be a Boolean. So we'll do like extra shot. And we'll have it be a full. There we go. That should be fine. And I'll have it be internal instead of private. We'll just set it directly. And that will update the price, I think, is what I want to do with it. We don't really have a way of overriding the price yet, so I'm trying to think of the best way of doing that. If we want to add an extra shot, then the GIMP info could display it instead of changing the price, you could just display it differently, and that'd be the easiest way to get around that for now. For later, we might try extra things, but I'm just trying to see the easiest way of doing it. And then um, pretty much the same for Americano. I said extra strong, but I mean, Americano can be extra strong. That can have an extra shot. Um, by the extra shot, it could be an extra shot of espresso, but it could also be like an extra flavoring if you want to do flavorings later. The extra strong is very similar, so I might as well just say that these both get extra shot instead, just to keep it simple. Let's do that. Have an extra shot. I'm not sure why I wouldn't charge for the Americano, but just to show that it can be slightly different, that we can have an extra shot, but let's just make it a different price, not a charge, but let's say plus 250, something like that for the extra shot. Just to show that we can do different things using the same methods. And this is going to be another slash. Okay, so we need arrows and things like that. If I can draw them from here. Yeah, love that. It's my mouse. Mm. I know you want to do that. That's what I want to do. Close, close. You get a new mouse. There we go. And then do this one. Yeah, swear. The only reason I keep this mouse is that I love how it rolls instead of the newer mouse that I have in my office. Of course, I'll change the arrow types. Cute. No. Yeah. Okay, now I'll change the arrow types to make sure that they are inheritance. And again, I'm just familiar with where these arrows are. It's the unfilled one for inheritance. Okay, so we can see some inheritance relationships, and we can see the association relationship, and we can see the composition relationship that we still have between menu item and coffee house over here. That's pretty much decent. I'd like to connect that a little bit better, but I'm going to be okay with it for right now. It should be able to still show the animation flowing. Yeah. Later I'll connect that a little bit better, but for now, that's okay. Okay, so didn't really want to do anything crazy with them, so that should be good enough. We have moved the drink out of coffee house, and we have moved the barista to menu items, so that's things we'll have to keep in mind. All right, so back to the code now. We need to implement those things. So first of all, I'm not going to worry about the program, but I am going to worry about um, the barista should be fine. That shouldn't change. We didn't change anything with barista other than where they were placed, what association they have. So instead of made by being here, and this would cause some errors at first, but we're going to move this over to menu item. And then in drink is going to inherit from menu item. And then we're going to get rid of this. And of course, it's going to say you can't have it be public, which is why we made it internal. And let's see, we don't pass in a menu item anymore. It is a menu item. And let's see, don't have this anymore. We can call the constructor from the base menu item class, which sets the made by, and let's say that will set the barista. All right, and then we'll say made by equal barista. No, equal made by back here. Made by equal made by. Probably just could call the barista barista. That'd make more sense for a name. There we go. Okay, now back to drink. Now we're not needing to pass in a barista to the drink because that gets passed in menu item. that we could. I mean, if we're going to create a cappuccino and things, we could call it with that and then call the base class from that. So we could do this and then say that call the base constructor. And the base gets a name, price, and barista. So we want to pass those into drink. So we'll do string name, decimal price, and we'll pass those in to the parent constructor. Okay, then we don't have a made by anymore. We still have a timestamp. And yeah, then we don't need to do this because we don't have that. We'll have to change up how we do get info to do it slightly different. Let's see, menu item. We don't have a get info here on menu item. So we'd have to print it from here, but we can do like that. You can even just do that. Since it does have access. That's the thing about giving it access to these things. Because internal is a way of giving access, protected is a way of giving access. So these are actually going to be inherited by this. So we don't have to say anything dot name. We just say name because it has access to the name property, the price property, and the made by property. I'm not sure why that's public. That should be internal. It would have been internal anyway, but nonetheless. And made by dot get info, that's called from a barista. And we'll just say the same thing. So that should change up our drink a little bit. Good. So I think that's all we had on the drink. Timestamp, we do have a milk type. So let's go ahead and give it a milk type. And for the milk type, I'll just go in here and make it a part of, and you can do this in different ways. You can make it a part of the program or you can make it a part of the class. For a drink, it probably actually makes sense to make the milk type part of the class. So I think I'll do that and just say for this, I am going to make internal and it's going to be num and it's going to be milk type. And then we need to give some values. So I can say whole, um, low fat, almond, soy, polka dot. I think that should cover some decent options anyway. You can always add more if you want. And then we probably want a way of saying the milk type on the constructor. So there's the enum. Now we actually have to create a type of that. And I'll just say, um, since I made this internal to the class, I'll have to call it something other than milk type. So I will call it internal, and this is going to be milk type, and milk type will be fine, but I think I just want type. If you didn't make it internal, you could do that. If I set this outside of that class, I could do that. But because it's inside, you have to use a different variable name that already exists here. So I'm just going to call it type. Or I could just call it milk. Milk might actually be easier to recognize. And then we will set that in the constructor. We can pass it along here. And I will do milk type. And I will use this to set it, say milk equals milk type. Okay, so that's just our constructor for drink, which gets each drink gets a different type of milk. We could also say no milk in case it's just a black coffee or something like that. Or if you have tea that doesn't have a milk, then you can default it to no milk or something like that. That gives you that option. We do not have class tomorrow. I don't know if it's a holiday or what, but we do not, in fact. So this will be the last time to see you until next Wednesday or hear from you anyway. I'll be online, of course. All right, so there is milk type, and that's milk, and that takes care of that. Yeah, so we can also say what milk type it has. We can say the price. We can say a lot of different things since our menu item doesn't have a way of getting info, I might want it to actually just do like we did before and give it an info thing here. And for that, I will do internal virtual get info. No, void get info. And for that, don't worry about I'm doing get info. I want to see for the other get infos, I probably have something other than a void. It's my thought. I must have gotten rid of them lately. There's a string right there. That's what I want to see. Yeah, we're returning a string for barista. And I kind of want to do the same format because it makes more sense to do that. So for menu item, I'm going to do string. And for this, I will return, and it's going to have the name, the price, the made by, I think will be good. Name, made by, let's see, name and the amount, price, price, and we'll do the made by. Okay. And then we can override it over here if we want into drink. And let's see, the name it is public. That's why. There we go. Has to say the same signature, including the access modifier. Okay. So this time I can say the name of the drink made by and I probably guess I could have done that for the menu item made by get info. That would make more sense. All right, so that shows information about the person that made it, the barista, which basically calls this name and ID. Okay, so this made by at timestamp as milk type and yep, sure, that should be good. And I want to do like a join for that. I want to do both the parent constructor for this and this constructor. So first I want to do string and let's say info is equal to base dot get info. And then we can do this. We can do join, but I'm just going to do a concatenation instead. I think, yeah, I'll just do this. Let's see, info. I'm trying to figure out how much did I actually print in the, I print the name and the price and who made it. So I don't need to do that again. So there's the name, who made it, and the timestamp. So I can get rid of the name and who made it and just do info since it already includes that information. So this will include the name and the price and who made it. And this will include the name, price, who made it at timestamp with the milk type. So just a little bit more information than what the parent gives us. And you didn't have to create a variable for that. You could do this and keep it tidy. There we go. That'll work. So that should give us some information. Now we need to create some classes for the Americano, for the cappuccino, and for the latte. So let's go ahead and do a new file. Yes. Yeah, okay. All right. So namespace. And we're going to use the same one, coffee. Oh, I didn't name it actually .cs is why. It's be a C# file to be able to recognize the C# instead of text. And then internal class cappuccino, which inherits from drink. And what do you not like? Let's see. No argument corresponds to. Oh yes, because we actually have to. Can you do a quick fix? Yeah, we can generate the constructor. That's what I was wanting to do, is actually generate the constructor real fast. So that will save me some time. So this automatically created the constructor that calls the base with the name, price, barista, milk type, and gives the information here. But for the cappuccino, we'll want one more piece of information. Cappuccino has the extra shot, and that would be internal bowl, and we'll say extra shot. So we will put that, and I'll tack it on to the end of this. Okay, and then extra shot. And see how we don't have to set any of these other variables because they're set by the base, the parent, which is in here, which in itself calls a parent. So that you can use base more than once. You can call it from the parent, which calls it from the parent, and you just trace back where you call from. But it saves you from having to write every bit of the variable information multiple times. So now I didn't have to set all these name, price, and everything else here. I just set it here. Okay, and that's the only thing I'm going to do with that, except I want to override the info from drink. Let's see, this one has this. Okay, so the base.get info for that. I'm going to update it a little bit from what the get info does, so I should be able to override that. Mainly because the price is going to be different based on that extra shot. So we can just do this. Let's say internal, and we'll do string get info. Let's say return. And this time I want to actually craft my own little get info. I want to do base. I was thinking about doing basic info, but it has to be different from a lot of this information that we're printing out. So I do want to get the information from that, which is timestamp, milk, and a bunch of other things like name, price, and made by. I do want all that information, but I want the price to change. So first of all, let's go ahead and change the price. So let's say um, price. We use an if statement. If you remember from last time, if a condition is true, it runs this code. And I'll see if the extra price, if the extra shot exists, if extra shot, which, so if the drink contains an extra shot, we're going to update the price. And the price, and this is going to be plus equal. And I think for the cappuccino, I said 5. Find my program. Yeah, for 5. That should be all right. I think I can do that. It's inaccessible. Have I made it inaccessible? Oh, because I made a private set and price. Let's go ahead and give it a little bit more access on this instead of a private set. Let's go ahead and give it a little bit more. All right. That way we can change it after it's created, which is what we need to do here. And I'm just going to add 5 to the price. And I don't need, since it's one statement, I don't need braces. But now I do need to override some things. Okay, so if I do that, then I should be able to use the same information as before on the base.getInfo. Okay, so that should return, and if I look at it, all right, so it has the parent's name and price, so that should already be updated with the new price. It has the timestamp, the milk type. The only thing I need to add to cappuccino is whether it has an extra shot. And for that, I'll say, no. Let's do this. And then we'll just do extra shot. Do it simply. This will either say true or false. That should be fine enough. Okay. And then did I return a string? Yeah, I need to actually override. There we go. And that overrides the implementation. Good. So all that should be all right. Now we have a cappuccino. I'm pretty much going to copy paste this code. Just change the price for the, I think it was Americano that I gave an extra price for. Yeah. And then latte price is based on the milk type. So I'll look at that too. But the Americano is the next one up because it's the easiest. Americano.cs. And then just, yes. And then this price, it just needs a, there. Okay. So it defaults to a double when on numbers. If you want to change it to a float, you have to use an F. If you want to change it to decimal, use M or capital M. Either way would work. Lowercase is usually used. And that will make sure that doesn't default to a double here and uses a decimal. Decimals are used for currency. So in C sharp anyway. So that's what we have for get info. And it's intentional that the price increases every time one gets the info. Yeah, kind of is right now. Because I'm only going to print the info once. Um, you can basically what's going to happen is I'm going to create an Americano, then get the info. If you want to prevent that, we have to have another method to do it, which we could do that in a different method instead of just doing get info. When we do it here, we could create it there and say if extra shot, we could just move that here for when it's created instead. You can do it like that. That works too. I was only going to do it in get info because I was only going to call get info once, but yeah, this would probably make more sense. So it's going to be set every time you create, and I'll do the same for cappuccino. Just move it to the creation. So every time you create an object, you'll check to see if you made it one with an extra shot, and so then it increases the price. That's what I was doing. Okay, so there's those. What else did I need? All right, so we got drink. Timestamp is kind of already done. So the only thing I think we really need is the latte, which varies based on the milk type. All right, so latte dots, yes. And I will just copy from this. I'm going to do slightly different stuff, but it's okay. And latte. Okay. Now it doesn't have to anything to do with the extra shot. Instead, we're going to use that milk type that we already passed in. And based on the milk type, we will see what we need to do with the price. So for, I don't know if I put it in the program that's yes or not. Yeah, for the milk alternatives, we're going to add 5, and for regular milk, we don't add anything. So we have to check the milk type. And let's go over, first let's go to latte to see if I've done anything. Right here. Yeah, we don't have an extra shot. I'm not probably going to override that, but we'll say. Probably don't need to override it for this one. But what we do need is the price to update based on the milk type. So we'll use an if statement as well. If milk type is equal to, and remember the double equals means comparison. And we're only going to check for the alternative milks, the almond, soy, coconut, or, and that's an or, double staff is or, and milk type dot equals soy, or milk type is equal to milk type dot coconut. Then we're going to increase the price and we'll say price plus equals 5.0 m semicolon. Okay, and then that should take care of that. And sometimes if you want to line them up, you can do something like that. If you want, I mean, you can put them all in one line. That's perfectly fine. But once you get to very long statements, you can break it up like that. It can be easier to see what you're doing. Okay, so we have almond, soy, and coconut, and I think that is good. Anything else that we needed? We actually have to use this stuff, of course. We haven't done that yet. We still have to update the coffee house. But that should be about it on everything else. In fact, I probably don't need to. override the get info for this. We can say what milk type it has just to see why it has that price. But I think in not menu item, but in drink, I think we already printed the milk type. Yeah. So we don't actually have to override that in the latte. So I'm just going to get rid of that and then we'll use the others. Now, we have a bunch of things here that we need to update because we no longer have a list of drinks made. So we need to get rid of that. And the menu item has more than just the name and price now. We're going to also have to pass in the barista that makes the menu item. So we need to get a barista, and then over here, and barista. Okay, so that's the first thing is that we need to update the way we add menu items. Of course, there's still more stuff. We no longer have a list of drinks made, so we're going to have to do this differently. And we don't have this stuff anymore, so we're going to have to do that differently. So let's go ahead with the drinks made. Instead of a list of drinks made, we do have a list of menu items. So we're going to process each menu item just like we did with show menu, but we're going to check to see if it's of the type of drink. Remember that when you're creating this inheritance relationship, you're creating one type that's more specific than another. So we're going to check the list of menu items to see if a menu item happens to be a drink, which is a more specific type of menu item. So we'll still process the menu items. Menu items, and then we'll say, okay, if item is, I think it's drink, and do we need to check anything else? I think that should be good on that. So all we're doing is checking to see if item is of type drink. I think that's good enough for that. So basically, we're not printing out the entire menu. We're looping through the entire menu and then seeing if the item is a drink, print it out and get the information from it. We could have done that with more specific, seeing if it was a cappuccino, seeing if it was latte or Americano. But I think we're just going to print the information for all the drinks made just to keep things simple. Now, as far as making a drink, we need to figure out what we need to add for that. So first of all, this has changed, right? So let's find out what actually has changed to. So I've forgotten. A new drink will go new, and we need the name, the price, the barista, and the milk type. So for this, all right, we're passing the name, which is menu item name or item.name, menu item name. Then we have the price, which we should be, let's see, the menu item has a price, so we can just say item.price. And then the barista should be item.made by. And then the milk type should be item.milk type, I think, is it? Or dot type? What was it? Trying to remember where milk type was. Drink.milk type, milk type. It might just be milk type. Figure that out. I think it's something else. Let's see. What did I put as drink? That's milk. That's why. That's what I'm looking for. Milk. Yeah, drink that milk. I'm milk. That's milk. What am I doing wrong here? Okay, let's see. Menu item doesn't contain a definition for milk, of course. That's right. So that's because not every menu item has a milk. So for making a new drink, we would need to pass in the milk type, not just the milk menu item name and the barista, but also the milk type. So for drink, we have milk type, and we have like a name and the price and barista and that sort of thing. So we're going to pass in the, and over here, the milk type as well. So for make drink, we'll also pass in not just who made it, not just the name, but the milk type. I'm trying to think where I want to pass it. This should be fine. Milk type, milk type. And that should work. And then we should be able to do, did I not give access to this? Yeah, I might not have access to that. It should be drink dot. There we go. Now we should be able to do that. And then we should be able to access that. Okay. Now we don't have a drinks made list anymore. So we can't add to that, but we can. So we need to figure out if we want to have a way of seeing what all drinks are made. All right, so let's make sure that we got the right accessibility. We probably need internal for, if I can type. And that should cause that not to have an issue because we made everything internal, which is fine. But that should be enough for information for making a drink. But we're no longer now adding to a list of drinks that have been made. So we could have we have a list of menu items, but we're not a list of menu items that have been made. So if you do want to get access like we had before of every drink or every menu item that's been made, then we're going to have to change up some things like add a new feature. So for now, I'm going to get rid of that feature just for the simplicity of it. Um, but if we want, we can always add back a feature that tells us what items have been made. Now, we'd have to change some things in program, of course. We can no longer do it like this, but we can do Java Joy add menu item. And now we need a name, price, and who's making it, basically. That's going to be, we should probably have like a blank for who's making it. Let's see, menu item. Yeah, if we want to say that it hasn't been made yet, I mean, we could say that we make it later. Then we could leave this as a null, which probably makes sense. But let's go ahead and at least say that each menu item that we're adding is going to be made by somebody. I know it can get a little bit complex and we'll fix it later, but not for now. Just making things simple for now, in other words. Because basically this says that I'm going to add a menu item, but it also has a barista when you make it, which is a little weird, but I'm going to, later on, we'll fix that. Okay, so for now, we'll be latte still, and for this, we'll do 38. And then we will have baristas. We need to add those first. And then we'll say, Emma. So all we have to do is add the barista on these. Magnus. And then Emma. And then later on, we can change up who actually made the item because, it makes more sense to say, okay, well, this is an item that gets added to a menu, but at the time that we make it, we shouldn't have to have a barista. For now, we do, but that's something that we would fix later on. I don't know if do we still have a make drinks? Let's see. Yeah, we do. But we have a milk type first. Let's go ahead and do a drink.milk type dot let's do almond and go ahead and make a drink dot milk type dot let's do whole, that way we know the price different, and drink dot milk type dot and coconut. And then we're going to change the way we're doing this just a little bit because this is going to try to make a drink with a name of latte, but we actually have a type latte. So we can actually just create a latte from our latte class. So when we do add menu item, let's see, name, price, barista, okay. But when we actually make the drink, that's what I'm looking for, drink, which is in the coffee house, I believe, make drink, yeah. All right, so we give it a name for what's being made, which you probably don't need. Probably instead of the name, we would want to put like the type, like the drink that we're making. We could say drink and put like, drink here. We could put like a menu type or something like that and do it that way. For a moment, I'm just going to keep things extraordinarily simple and keep things exactly the way they are, just so that we don't change too much from the last version of the program. Later, I will get rid of this entirely because we don't need it anymore. We have a type latte instead of a string, so we don't need that. Now, if we make the drink, it should still do it correctly, though. If I can go back to the coffee house, it should still make the drink with the new price, I think. So let's find out. I think everything should be correct. But again, there are things that we'll want to change based on this new structure, like the latte, cappuccino, espresso we wouldn't want here. When we add a menu item, we should at least allow the barista to be blank. Then whenever they actually make a menu item or make, and we have make drink, but maybe we should have a make menu item instead, for instance. Then we would put the who made it by. Those are two things I would think I would change, but for now, we'll try and see what happens. And let's find out. All right, so let's move this up. Come on, mouse. All right, creating a new coffee house, creating some baristas, adding menu items, and showing the menu. Okay, so we still have the latte, we still have the cappuccino, and we don't have any drinks showing anymore because we no longer have a list of drinks. So we want to actually show that. I mentioned that we would have to actually and make drink probably called get info or something like that. So in make drink we could do that just to show it. So we have a new drink, which is good. And after we make the drink, we should probably print the info right here, I'd say. So new drink info, and that will return a string. So I'm just doing console.writeLine and just going to print some information about it. So now we have the information about it. So when it creates a drink, it says which drink was created, how much it cost, who it was made by, and what time it was made by, and what type of milk it had with almond. So now we actually have the information that we need. So this is showing we actually have the full composition relationship now because we no longer have a way of creating a menu item outside of the coffee house anymore. It's no longer part of drink. Drink has the milk and timestamp and things like that, but that is the entire thing. And yes, I yeah, I did it last time. I will go ahead and upload the code and the UML diagram just like I did last time. And it just takes me a little bit to gather everything together. I can't actually upload the VOD to It's Learning, but I can to YouTube. So in YouTube, there should also be a link to in the video to the information as well, but it should also be on the It's Learning. But yes, I will for sure. And I might update some things, put some more comments and things and like that. But I didn't last time, so we'll see. But yes, I will for sure. But this is pretty much everything you need on inheritance. So we created a latte that has some basic information. All it did was update the price. We have an Americano that could have an extra shot and that had a different price than the cappuccino. So that's all shown. And yeah, so that's updated and we have all the information. So are there any questions about any of that? Because there was quite a bit of inheritance that we did. And again, I would update some structure some just to show a little bit better information. But yeah, that works for now, I think. So any questions at all? Yep. Yeah, there's different ways we can do things, but this showed us exactly what we wanted to see on the inheritance relationship. And it created the relationships that we have in the classes that we suggested. We had the get infos, we had the extra shots, we had the milk type, we have the, which we displayed. We have baristas now associated with menu items instead of with drinks. But again, that's something that we will probably want to make like a nullable barista. That way we don't have to add it right when we add a menu item. And whenever they actually go to process a menu item, like someone orders something, that's when we put the made by at that point. That's why I would say that would be a suggestion for a change. And also getting rid of the just strings that we're using for latte, cappuccino, and Americano, instead just making use of the types. Those are the two changes I would make from what I've done currently. Otherwise, it should work fine. If there's no questions, I guess we can let you head for the week, I guess. I'll see you next week. I've had to cancel several streams because of the whole virus, but hopefully I'm well enough to be able to do some more streaming, both educational and game streaming. I do plan on doing the Monday stream for educational content, but it will probably be, since I think most of you have class in the morning for my own students. I think what I'll end up doing is have it for later in the afternoon or evening, which is more of a review. It'll start from the day one. So that one's going to be a review, and for people that are new to the course and that sort of thing, so that it doesn't seem out of place for the people that are just learning and just starting out, and so that the people that have had the course and up to this point can start over and like say, okay, well, this is the get a refresher for the exam that's going to come up. Okay, otherwise, I guess I will wish you a good afternoon. Have a good day. See you next week, or hear from you at least.